Hi, my name is Susan Bernard. I'm the CEO and founder of Textile Instruments. We're going to have our CTO also describe the technology and go through our presentation. One of the main things I want to describe is what the innovation timeline really looked like for us. I know some folks asked, well, how do we have access to these technologies? So in 2011, there was a presidential memorandum where there was a call for accelerating technology transfers, specifically moving them out of the federal laboratories and into commercialization. And it was really meant to facilitate and support high growth businesses. In 2012, I attended the NASA Technology Days in Cleveland. We were then in 2013 invited from a group from the NASA Langley Labs to a workshop. We then participated in the NASA Technology Roadshow that came to our hometown of Toledo, where our concept and our idea was a winning concept and a winning idea. We then received the ability to spend time with NASA Glenn. In 2014, we decided that we had an interesting concept, and we went ahead and we applied for the technology transfer. That's when Textile Instruments was born. We did receive an exclusive license in 2015, and in April of 2016, we now were able to go from a sensor, SANS-EC sensor technology to a fabric-based sensor, and is actually outperforming the original sensor that we were exposed to. So with that, I'm going to allow Rob Donnelly, our CTO, to describe some of the innovation that we're experiencing in our labs today. Thank you.
Once again, thanks for having us. My name is Rob Donnelly, CTO of Textile Instruments. As Susan mentioned, our technology was born out of the technology transfer program with the Electromagnetics Research Center at Langley. They had come up with a very unique electromagnetic sensing device that's passive, much like an RFID chip that we use in the radio spectrum, although this one operates in the magnetic spectrum. Originally developed for aviation applications. As Susan showed before on the triangle sensor, this was developed for a rigid, or it was originally developed to be a kind of a rigid base material, and we've turned it into a fabric. And once we did so, we realized there's a host of other applications for the technology. One of those is in healthcare. So the sensor has a unique ability to identify unique electromagnetic events that are near it, and when it responds with a reflection signal upon being impeded by like a Wi-Fi router or a wall source, information about its state is carried back to the transceiver. We can look at things like the temperature. We can look at a timed interval that we know we're looking for in a heart rate to determine heart rate, presence of touch and pressure, whether or not it's surrounded by fluids, and if those fluids are electrolytes or not. And also if you're asleep or awake. There's some amazing things and information that's in the body's magnetic spectrum that if we can listen to it, we can identify. So one of our potential applications for this in healthcare is to eliminate the need for cumbersome wires to be attached to take vitals. I don't know if anyone has experience being nurses, but they typically have like a 12-wire telebox. There's 12 things connected to you while you're in surgery. A caregiver could trip over one or disconnect one from a wall and an alarm can sound off. If we can monitor all of these things in an integrated textile, the simplicity is very beneficial. So a couple months ago, we went back to the Langley group and we showed them what we had. And Susan has a T-shirt that she's holding with one of the sensors in it. And it's important to note that this is a passive sensor. Much like an RFID chip, there is no battery and there is no hard plastic puck or anything. This is in the cloth. And we did a temperature demonstration with them and also demonstrated heart rate and moisture detection. So Key attributes of it: open circuit sensor, no electrical connection or battery. It's biocompatible. It's made with FDA-approved materials. We can do all those measurements with only one sensor, just looking at different aspects of the magnetic field. There's very low RF emission. The size of it is very, it's low profile, integrated into a textile. It's washable. There's one of the reading units we have. You can see it fits in the palm of a hand, so it's not bulky. You have real-time data collection, and we think the system from where it was is now quite miniaturized. Another unique thing about this system is that you can produce tuned sensors to be identifiable. Much like RFID, you can tell who's at a door. You can tell whose heart rate you're watching. Potential applications, activewear, sportswear market. If you had the entire NFL team's, stress level and heart rate on an iPad, you could monitor that all at the same time. Spacesuit, you could wirelessly monitor vital signs without having to be connected to a wall or worrying about batteries dying. Incontinence products is huge. The second highest cost to the Medicare program is complications due to incontinence. So if someone basically wets themselves and doesn't get changed quick enough, you end up with a kidney infection or a UTI. They spend more money fighting a preventable cause than actually treating causal diseases. So another thing it can do is monitor the quality of textiles, whether they've been damaged or not. If the sensor becomes damaged itself, it reports back that it has been damaged, and so there's some applications there. Particularly in like surfaces of a vehicle or an airplane, or even in like a protective vest situation, like a bulletproof vest. There's also applications for remote industrial monitoring. These are just some slides on some of the projects that the LARC has done and where they think it could be applicable. This is a state of our technology. If you'd like a copy, this presentation, please contact one of us after. And right now we're seeking funding to commercialize this technology in 3 different verticals. We're at the point where we have, like a preliminary beta working system, and as we listened to Austin's presentation earlier, now we're at the point where we need to have some empathy-driven design take place so that this can be viable in a commercial market. This is just a team introduction. I won't need to go through it and spend time on that. And here's our contact information. Thanks for having us.